I'm sorry to tell you, the only thing that's been to space is your imagination. There is no such thing as space. For thousands of years, all ancient civilizations knew the Earth was flat. When an organization of pseudoscientists tell me to go completely against what all my senses tell me, that we're stationary and flat, I see it's flat, it's immovable. And I'll go outside when I send a camera up without GoPro or fisheye lens. When I send a balloon up 100,000 feet and it shows the horizon flat, I can't go against that. When I see skylines 60 to 100 miles away, when spherical geometry says they should be behind the curve, all this stuff isn't adding up.
What is theoretical physics? Well, theoretical physics uses math and theory in order to come up with or derive the fundamental laws of nature and to make conclusions from these laws. Yep, ideas and mathematics giving little to no weight to experiments or observations. Sounds fun, huh? Books have been written and questions have been asked because to some it has become obvious that physics has been stuck for years because the belief in beauty and math have become so dogmatic that it now conflicts with scientific objectivity. That a focus on mathematical elegance rather than reality has led the so-called science astray. It reminds me of a quote from Nikola Tesla, who of course was a real scientist, not a theoretical physicist, who said, "The scientists from Franklin to Morse were clear thinkers and did not produce erroneous theories. The scientists of today think deeply instead of clearly. One must be sane to think clearly, but one can think deeply and be quite insane. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality." Nikola Tesla. Things like dark matter, string theory, the Big Bang, quantum gravity, relativity, and so much more have all come from the minds of theoretical physicists. Let's list some of these theoretical physicists because maybe you've heard of some of them. Nicholas Copernicus, who formulated the Copernican principle that the Earth or human beings could not possibly be in a privileged position in the universe. Or Giordano Bruno, who told us that the stars are just like other suns. Or Galileo Galilei, who pushed the ideas of heliocentrism. Or Johannes Kepler, who came up with mathematical laws of planetary motion. Or Isaac Newton, whose cannon-shooting thought experiment gave rise to gravity. Or Christian Huygens, who in 1653 came up with the distance from Earth to the Sun when he guessed, yes, guessed, they say correctly by chance, the size of Venus, allowing him to measure the Earth to the Sun distance. Or Father George Lemaitre, the Jesuit, who came up with the idea of the Big Bang. Or Henry Cavendish, who used balls in his shed to correctly come up with the mass and weight of the Earth. Or Max Planck, who was the originator of the quantum theory. Or Albert Einstein in relativity and the bending of space-time. To more recently, Lawrence Krauss, who tells us that something can come from nothing if you have gravity. Or Michio Kaku, who tells us all about string theory. Of course, there are thousands more. To see a pretty decent list, check out the link in the description to Wikipedia, where you can see the many other names like Stephen Hawking, Richard Feynman, Ernst Mach, Max Born, Ernest Rutherford, James Clerk Maxwell. The list goes on and on. But I want to come back to one in particular to help us answer our question, and that is Michio Kaku. In a recent interview, Michio Kaku said the following. Now listen carefully, as I believe he gives us the answer pretty much straight up.
You're not going to believe this. In science, we always say that you make observations, you have a theory, you go make more observations, and it's a very, very tedious process. Wrong. Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
In that quote, I believe we find our answer. He said, plain as day, that nobody that he knows of in his field, and his field is theoretical physics, uses the so-called scientific method. Why is that so important? Well, it is so important because when we look at the definition of pseudoscience, we see clearly and everywhere that by definition, pseudoscience is a collection of beliefs or practices mistakenly regarded as being based on the scientific method. Yes, pseudoscience consists of statements, beliefs, or practices that are claimed to be both scientific and factual, but are incompatible with the scientific method. One more time, in case you missed it, from Michio Kaku himself.
Wrong. Nobody that I know of in my field uses the so-called scientific method.
And when you don't use the scientific method, what you practice is no longer called science. It's simply called pseudoscience.
In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork. Guesswork. Guesswork.
Guesswork. Just great. And do some research on the difference, and you will see what we are being fed as factual and reality is simply guesswork. This chart shows the characteristics of pseudoscience versus actual science. Pseudoscience avoids falsifiability. It has vagueness in measurement. It takes what is unproven as false equals true. It has confirmation bias. It spends money and resources without care and has a reversed burden of proof. Sounds a lot like the Big Bang, universe expansion, dark matter, relativity, space-time, black hole science, unification theory, the theory of everything, supersymmetry, string theory, gravity, and on the list goes. So next time you hear these theoretical physicists talking nonsense, make sure you remember that the evidence speaks for itself. But it's up to you to decide. Is theoretical physics pseudoscience? I think the answer is clearly yes. Or you can continue to believe these guys and take the things they say as fact, like when we asked Michio Kaku to explain string theory.
Because we have a theory called string theory. It is fantastic. It is incredible. It has astounded the world of mathematics and physics. And now you can't move in the physics world without bumping into somebody who wants to talk about the 10th dimension, the 11th dimension, the multiverse, hyperspace, time travel. All the things that were once considered science fiction are now centerpiece in our understanding of the nature of everything.
Yes, the 11th dimension, the multiverse, hyperspace, and time travel, things that are so clearly science fiction, are now centerpiece in our understanding of reality. Or when someone asks Lawrence Krauss how the universe was created from nothing, and he gives this answer.
Let me just give a 1-minute answer because it's a long. What is remarkable is that to create stuff, it sounds like you need stuff. And to create stuff, and the conservation of energy, you would think, and this is where the argument's often used, conservation of energy means you can't start with nothing and have a universe with something. But what is amazing is when you add gravity into the mix, a miracle occurs, but a natural miracle. That gravity allows negative energy as well as positive energy configurations. And you can create, for example, two particles out of nothing. Now they have energy because of their rest mass. But if the gravitational field they're in is strong enough, the gravitational potential energy attracting them together is so strong and negative that the sum total of those two bits of energy can be precisely zero. And you can create those particles with impunity. And in fact, that happens, we think, near black holes. And in fact, it will happen in empty space. And so in fact, to create stuff, you don't need stuff. You just need nothing. And in this case, quantum mechanics.
Well, then you'll know that the reason these answers don't make any sense at all is because they are nothing more than pseudoscientific junk. Period. Of course, you are free to your own opinion. Maybe you have a different answer, but when somebody asks me, is theoretical physics actually pseudoscience? The easy answer is yes. Last thing is, I don't want to give Michio Kaku too bad of a time because as time goes on, he's actually figuring it out a little bit. This quote he gave actually makes me feel a little bit better that some of these guys do see the light at the end of the tunnel. He said, "I've concluded that we are in a world made by rules created by an intelligence. Believe me, everything that we call chance today won't make sense anymore. To me, it is clear that we exist in a plan which is governed by rules that were created, shaped by a universal intelligence, and not by chance." Imagine that.
Usually in science, when we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120th. That is a 1 with 120 zeros after it. This is the largest mismatch between theory and experiment in the history of science. Wow. Why don't you guys knock off at least 100 zeros and get back to us?
Ladies and gentlemen, Steve, Deceive.
Let me just explain that what happens when Professor Hawking wishes to speak. He lost his voice a couple of years ago and now has to use a voice synthesizer, and he can control a squeeze box in his hand, and on the VDU screen on the arm of his chair he's got a vocabulary which scrolls through, and he can pick out the words that he wants, and these words are then assembled into a sentence, and when the sentence is ready then he can process it through the voice synthesizer. So whenever you're ready, Professor Hawking, we'd like to hear from you. Professor Hawking.
Never gonna give you up, never gonna let you down, never gonna run around and desert you. Never gonna make you cry, never gonna say goodbye, never gonna tell a lie and hurt you.
add up all the stars, the galaxies, the planets, the comets, the black holes, the dark clouds, everything out there that we can see, touch, smell, or taste. And it doesn't add up to give us the gravity that we see operating in this universe. So really, we should be calling it the dark force, because we don't know if it's made of matter. It could be a profound misnomer, sending people off in thought directions that might not really be the right path. So dark matter is just simply what we call this thing about which we know nothing, responsible for 85% of the gravity of the cosmos. It is the longest standing unsolved problem in modern astrophysics. Dark matter, dark energy. Everything we know about the universe, what we're made of, galaxies, stars, planets, that's all right here. So, according to this chart, we are 96% stupid.
What is space-time?
You already know. You have never met someone at a place unless it was also at a time. You have never met someone at a time unless it was...
Okay, I get well, wait a minute. Wait a minute. What happens to a photon from 13 billion point 800 million years that comes this way and enters my eye so I can see it? Why? Where's space involved in that?
It entered your eye at a time and at a place. Right here. That's all that matters here.
Is that all we're saying?
Well, once you have formalized space and time and know that they're conjoined, then you can make all kinds of fascinating calculations.
What a great science fiction story.
And not only is it, the universe is under no obligation to make sense to William Shatner. Okay?
No, but William Shatner's under the obligation to make sense of the universe, as is you are doing. And why do I slow down as I approach the speed of light?
Okay, the faster you go, the slower time ticks.
Say that again?
The faster you move,
yeah,
the slower
that's
time
what you
ticks
just said, yeah?
for you,
yeah,
as seen by others.
Right.
As you approach the speed of light, time continues to slow down.
Yes.
At the speed of light, time stops. Which means for a photon moving at the speed of light, when it is absorbed in your retina, it is the same instant it was emitted at the Big Bang 14 billion years ago.
Big Bang. What a great science fiction story.
I know that came from the Big Bang, and I'm watching it, and it's taken 13.8 billion years to reach you.
Big Bang. What a great science fiction story that.
It's Big Bang 14 billion years.
Million, billions, billion, trillions, billion, million, trillion, billion.
I took astronomy from Carl Sagan.
So, gravity waves were predicted to move at the speed of light in Einstein's equations, and if you have a graviton, the propagator of gravity, that would also move at the speed of light. So there you have it. Now, we've never detected a graviton. Or directly have we detected, nor have we directly detected gravity waves. But we have top people working on it. There's the Laser Interferometric Gravitational Wave Observatory, shortened to LIGO, is a multi-location observatory that uses high technology lasers and interferometers, where it knows the distances between 2 points in long tunnels accurate to like the width of the nucleus of an atom. Now, we've never detected a graviton. Or directly have we detected, nor have we directly detected gravity waves. But we have top people working on it.
What is gravity?
We have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know. What is it? I think Einstein, in an Einsteinian answer, we would say gravity is the curvature of space and time. And objects will follow the curvature of space-time, and we interpret that as a force of gravity. That's probably the best answer I can give to a what is gravity question, or why is there gravity?
Astrophysicist looking out there is thinking in terms of science fiction.
No, I mean, Earth, to the astrophysicist, we don't really care much about sea level. No.
When you get up in the morning, doctor, what do you do? And he says, it's all in my head. I think. I said, well, how do you prove what you're thinking exists? Because it's all theory. He said, well, I've got this very elegant numbers equation, yeah. Very E/B divided to 7 to 4. It's all in his head. How do you prove a black hole? How do you know those gravitational waves proved the collision of two black holes?
Somehow, eventually, they are able to observe phenomena.
No, they can't observe. It's too far away. It's too theoretical. How do we know what they're saying is true? You know what it really is? It's all science fiction.
So does that make you a skeptic?
No, well, science fiction says this is a story that I'm making up.
My question is, through your career and your writing and your acting, you've inspired so many people to enter the sciences. How do you balance science with science fiction?
They're both the same.
I should tell you that the first mission is scheduled to land on Mars on July the 4th, 1997, Independence Day.
We will undertake extended human missions to the moon as early as 2015, with the goal of living and working there for increasingly extended periods of time.
One thing I really want your generation to embrace is that the Earth is a closed system. We cannot leave the Earth.